Okay, now we will mention about the planes. Again, we will give various equations for the plane. So first we start by this one. An equation of a plane passing from the point, let's say P sub 0 again, X sub 0, Y sub 0, Z sub 0, and perpendicular to the vector, let's say n equals ABC. Now let's say you have these this is our okay, this is our plane, let's say. So it is passing from this point. Let's say this point is P sub 0. And then you have this perpendicular line here. This perpendicular line. So this perpendicular. So this one is N. N is ABC. So we know that it is X sub 0, Y sub 0, and Z sub 0. This is P sub 0. And then we are trying to find these equations. So let's say we have this P is here, this P. So P is a arbitrary point, okay? X, Y, Z. From the graphic, you see these P sub 0, P, this line segment, is a vector, is perpendicular to this N. So it is 0. Because they are perpendicular to each other, they are orthogonal. It means their inner product is 0. So then, if we write this P sub 0, P is x minus x sub 0, y minus y sub 0, z minus z sub 0. Okay, so then if you put this information here, we have x minus x sub 0, y minus y sub 0, z minus z sub 0 times a, b, c. So this inner product. So from here we have this one, a times x sub 0 plus b times y minus y sub 0 and c times z minus z sub 0 equals 0. So if you arrange this equation, we have this one, a x plus b y plus c z minus a times x sub 0 minus b times y sub 0 minus c times z sub 0 equals 0. So this one is a number. So let's say this number is d. So this is the equation. So the equation of the plane becomes a times x, b times y, c times z plus d equals 0. So here you see this a, b, c is already given, is called the normal vector of the plane. So if the normal vector is known, we know a, b, c. Okay, so we can write directly the plane. So we can define the plane, okay, by using this plane can be defined as the subset of R3 such that so x, y, z, this is the point R3, such that a times x plus b times y plus c times z plus d equals 0. So this is the definition. Okay, now let me give one example. Find the equation of the plane passing through the point passing from through passing from through the point to -1, 3 and perpendicular to the vector 3, 5 and 4. So we will use two methods here. The first one is this. Let's solution 1. So we know the P sub 0 is this. 2, -1, 3 and N is this one 3, 5, 4. So choose an arbitrary point, P, X, Y, Z. So then, as we did in the above equation, P sub 0 P is this one, X minus 2, Y plus 1 and Z minus 3. So then P sub 0 P inner product N will be 0. So if you write these vectors here, so then you have 3 times X minus 6, 5 times Y plus 5, 4 times Z minus 12 equals 0. So if you arrange this equation, 3 times X plus 5 times Y, 4 times Z, negative 6 plus 5, negative 1, negative 13. So this is the plane we were looking for. Okay, how about solution 2? So the normal vector normal vector n 3, 5, 4 implies that we have this one 3 times x, 5 times y, 4 times z, plus d will be 0. So if we find d, then we find the equation. But we have this information, the plane, the point, which point? Point 2, negative 1, 3. 2, negative 1, 3 must satisfy the above equation. Okay, so it means when you put this point in this equation, the equation will satisfy it automatically. So let's put. So 3 times 2, 5 times 1, 4 times 3 plus d will be 0. So 6, okay, you see 6 minus 5, 12 plus d will be 0. So d will be negative 13. So if you put this d here, 3 times x, 5 times y, 4 times z, minus 13 will be 0. This is the same equation, is it? Yeah. We will use generally this second solution, okay, because it is more practical. Okay, another example. Find the equation of the plane passing from the point (3, negative 1, 2) and having the normal vector 4, 1, 3. So having normal vector, it means the plane is perpendicular to this vector. Okay? Okay. So actually there is nothing new here. We will use the same method we use in solution 2. So again, we have this one because n is 4, 1, 3. So it means you have 4 times x, 1 times y, 3 times z, plus d equals 0. So if you put this point here, you have 4 times 3 minus 1, okay, and 3 times 2, 6, plus d equals 0. So, okay, 18 17, right? D will be 17. So our plane is 4 times x plus y plus 3 times z minus 17 equals 0. This is the plane. So generally we think the plane is a plaque, but it is not correct. It's not plaque, it's the top of this plaque. Okay, this is our plane. Of course, plane, there is no boundary for the plane. But in the actually, how about the normal vector? This is the normal vector. Which one? Okay, let me show that. The red one. So this is the point. This one. Okay, so another. Of course, I derive the graph, the normal vector from the origin. Okay, so let's derive this vector from the 3.3, negative 1, 2. Okay, let me change this one. Three, negative 1 and 2. You see, this is the normal vector. This is our point, the black one, and the red arrow is our normal. Of course, in every point, this is perpendicular to the plane. Okay? You may change this one, but because it is passing from this point, I just derived that point. So these are, okay, let me put in this way. Okay, this is much better. This is our plane. Again, there is no bound. An equation of the plane passing from three points. Okay, let's say you have plane okay, So we have this plane. Let's say you have 3 points here. So let's say this P1, P2, P3. So P1 is this one, X1, Y1, Z1. P2 is X2, Y2, Z2. And P3 is X3, Y3, Z3. So in our first method, we need a point. We already have 3 points, right? So we have plenty of points, and we need a one perpendicular vector. So here we need to construct the perpendicular vector. Okay, so let's consider this. This is the one vector. It's not perpendicular, it lies on the plane, so this is not the we are looking for. So another one, this one. So this is also vector, but it is lying in the plane, so this is not we are looking for. But if you look at this one, the third, okay, this one is P1, P3 cross product P1, P2. So P1, P3, P1, P2, this cross product vector is perpendicular to the plane. Therefore, we can think of, or we can consider the P1, P3 cross product P1, P2 as the normal vector. So if we choose arbitrary point x, y, z in the plane. So let's say your arbitrary point is here, this one. So then this will be perpendicular, right? So then we have this one, P1, P3 cross product P1, P2 P1x, P1p will be 0. So this is P, x, y, z. So what does it mean? So if you look at this one, this is the mixed product, right? Because there are cross product and inner product. So it means this is a mixed product. So this means you have determinant P1, P3, P1, P2, P1p, and we know that this one is also equal to this one, P1p, P1 P3, P1 P2. Or I can change this one because the right side is 0, so I can write this P2 and this one. P1, P2, P3. So this tells us you have this one. Okay, this is the P1P, x minus x1, y minus y1, z minus z1, the other one, x2 minus x1, y2 minus y1, z2 minus z1, and the other one, x3 minus x1, y3 minus y1, z3 minus z1 equals 0. So this is the equation of the plane passing from three points. So it means 3 points determine one unique. We will give one example for the plane passing from 3 points. So this example. Find the equation of the plane passing through the points, let's say P1, (1, 2, -1), P2, 3, 2, -1, and 3, 4, 2. Now, we already mentioned about the formula about this plane if 3 points are given, but here I will give 3 methods you can use to find this equation. So our first solution, the usual one, solution let's say 1. So we know the equation of this plane determinant Px, P1x, let's say, P1, P2, and P1, P3 equals 0. So here x, let's say x, y, z, is arbitrary point. Arbitrary point. So this tells us we have this one. Let's say is a determinant. So x minus 1, y minus 2, z plus 1. And then P1, P2, 2, 0, and 0. And P1, P3, so this one is 3, P3. Then you have 2, 2, and 3. So we need to find this determinant. To find this determinant, I expand this determinant by these 2. So you have this one, negative 2 times. So I am here. So 3 times y minus 2 minus 2 times z plus 1 equals 0. So negative 2 is not 0. So we have this one, 3 times y minus 6, 2 times z minus 2 equals 0. So 3 times y, 2 times z minus 8 equals 0. So this is the equation of the display. Okay, this is solution 1. Solution 2. So in this case, we know the equation of the plane. We know that a times x, b times y, c times z plus d equals 0. This is the equation of the plane. Because P1, P2, and P3 should satisfy this equation. So it means when you put this P1, P2, P3, always this equation, the plane equation, should be verified. So let me put these values here. So first one, a plus 2 times b minus c plus d equals 0. Second, 3 times a, 2 times b minus c again plus d equals 0. And the third one, 3 times a, 4 times b, 2 times c plus d equals 0. So you have this system. So these are the linear equations, right? So we can solve this equation. There are several methods, but in this first semester you'll solve the elementary row operations. So we will write as matrix. So if you write a matrix, you have 1, 2, negative 1, 1, and 3, 2, negative 1, 1, 3, 4, 2, 1. Okay, this is my matrix. So I will apply the row operations. So as you see, instead of row 2, I will multiply negative row 1 plus row 2. And row 3 now becomes negative 3 times row 1 plus row 3. Okay, now I will make these calculations. So first row we remain same. Second was 0, negative 3 times 2, so this one negative 4, and 3 minus 1, 2, negative 3 plus 1, negative 2. Here 0, negative 6 plus 4, negative 2, 3 plus 2, 5, and now negative 3 plus 1, negative 2. Okay, now so I will reduce to the echelon form, but at least I will make a couple of components 0. So now I will try to do this one, row 3 instead of row 3, negative 1/2 row 2 plus row 3. So the first one remains same, the second one remains same, and the third one 0. So 1/2, this one 0, negative 1/2, so this one will be 4. So this one negative 1, no, it become 1, so this one will be 1, negative 1. Okay. I can stop here, or you can continue. So if I stop here, I have this one. Now let me write the equation again. So A plus 2 times B plus minus C plus D equals 0. Okay, this one negative 4 times B. Okay, let me write in this form. Negative 4 times B plus 2 times C, negative 2 times D equals 0. And this one 4 times C minus D equals 0. Now there are 3 equations, 4 unknowns. So I can choose one, 4C. Okay, let me write here. 4C equals D. So C becomes 1 over 4D. So if I put this information in the second equation, 4 times B plus 2 times 1 over 4D minus 2D equals 0. So negative 4 times B. So here 1/2 D, 1, 2 minus 2D. So negative 3 over 2D. So this one 3 over 2D. So B becomes negative 3 over 8D. Okay, now I will find the A. A becomes 2 times negative 3 over 8D. This one becomes 1 over 4D plus D equals 0. So these cancel each other. Negative 3 over 4. So A becomes negative 3 over, yeah, A becomes 0. So I have this equation now. A is 0, B is negative 3 over 8D times X plus C 1 over 4 D times Z plus D equals 0. So d is not 0, because if d is 0, everything will be 0. So we have negative 3 over 8x plus 1 over 4, not x, this one. This one is y. So 1 over 4 z plus 1 equals 0. So the result is this one. Negative 3 times y plus 2 times z plus 8 equals 0. So if you compare this one and this one, will be same, right? The equation is same. 3 times y, negative 2 times z, negative 8. So this is the same. Okay, this is the second method. So third method, solution, let's say 3. Actually, this one is similar to the first one. Now we have this plane. So we have this plane. We have 3 points here, P1, P2 and P3. So you have this line segment. Now we need to find the normal vector. Normal vector will be perpendicular to this one. So this will be perpendicular. So that's why, and the normal vector will be P1, P2 cross product, P1, P3. Okay. So let's find this one. So n will be P1, P2. P1, P2. If you look, yeah, P1, P2 will be 2, 0, 0. P1, P3. P1, P3, 2, 2 and 3. So you see this one becomes 0 and negative 6 and 4. So this is normal. So it means our plane is this: negative 6 times y, 4 times z, plus t equals 0. So because our plane is passing from these 3 points, I can choose one of them to put to this equation. So let's choose the first one. So first one is 1, 2, negative 1. So if you put 1 to negative 1, 6, 8, okay, 1 to negative 1. So this one will be 12, 4 plus d equals 0. So you have d as a 16. So the plane will be negative 6 times y, 4 times z, plus 16 equals 0, or you can write okay, this one. Okay, now this one. The plane passing from the point only one, x sub x1, x1, y1 and z1, and parallel to the vectors let's say v1, a1, b1, c1, and v2, a2, b2 and c2. Now again, we have this plane So because we have this plane, it means we have a normal here, and let's say this is our point P1, this n. Now we have two lines, two vectors parallel to this plane. So let's say one of this one, the other one is this one. So this V1, let's say this V2. Of course, when you drive the graph in the plane, it looks like this V1 and V2 also parallel, but it may not be. Okay, in the three-dimensional space, it may not be. So, but let's drive in this way. So from this we know n is perpendicular V1 and n is perpendicular V2. So this tells n will be V1 cross product V2. So then the problem reduces to the plane passing from P1 and perpendicular to n. So this is the first one we mentioned about. In our first method, we say if you have one point, your plane is passing from that point, and also if you have vector, your plane is perpendicular to that vector. So this is the problem. This problem. Okay, let me give one example for this one. Find the equation of the plane passing from the point P1, let's say 1, -1, 2, and parallel to the blue lines. So our lines is this. And okay, try solve this problem by yourself. So let's check later. Here the vectors are not given, so two lines are given. So vectorial part or the direction vectors will be our vectors because direction determines the parallelity. Okay, so we have this one, right? So for this one, D1, let's say 3, 2, 4, and D2 is 0, -2, 3. So our n will be D1 cross product D2. So if you write this one 3, 2, 4, 0, -2, 3, so then we find 6 plus 8, 14, 9, yeah, this 0, this -9, and the last one -6. So our plane is this. Here a times x. So let me write directly. You have this one 14 times x, -9 times y, 6 times z, plus t equals 0. So now put this p1, so it means times 1, 9 times -1, and 6 times 2 plus t equals 0. So here 14, 9, -12 plus t equals 0. So d becomes 11, right? -11. So our plane we are looking for will be 14 times x, 9 times y, 6 times z, minus 11 equals 0. Okay, you see the blue one, the yellow one, and the plane. So the line, okay, let's check the line. You see line in this form, not parallel, okay? In the, you see in the, okay, this one. Actually, we don't know. Maybe they intersect each other, not, but at least we see they are not parallel, okay? Okay. So this is the plane. Maybe I should, okay. Yeah, this is better, okay? This one, intercept form. Intercept form of the plane. Okay, now consider this plane. This one. Consider the plane A times X, B times Y, C times Z plus T equals 0. So then we can write this one. Of course, D is not 0. Then we can write A over D X negative plus negative B over D Y C over D Z equals 1. Or you can write this one, negative D over A plus Y over negative D over B plus Z over negative D over C equals 1. So this one, let's say A, this one, let's say B, and this one, let's say C. So we have this one, X over A, Y over B, Z over C equals 1. This is the intercept form. Okay, so the plane, this shows that the plane intersects x-axis at A, y-axis at B, and z-axis at C. Or if you write the our 3 points, so the plane or this equation shows that the plane passes from these 3 points, A 0 0, B 0 B 0, and 0 0 C. Okay. Consider this example. Find the equation of the plane passing from the coordinates x axis, let's say, at 2, y axis at 3, and parallel to the vector, let's say u, 2, -1, 3. Okay, let's say these coordinate, not coordinates, axis. X-axis, because it says it's passing from the axis, it means you have this form: x over 2, y over 3, plus z over, let's say, c equals 1. Okay? And because the plane is parallel to the now, because let's say this is a vector, our plane is parallel to this vector, so it means this n will be perpendicular to this vector. Because we know our plane will be a times x plus b times y plus c times z plus t equals 0, right? So it means you have this one, n 1 over 2, 1 over 3, and 1 over c. This is n. And n is perpendicular to u. So you have this one. 1 minus 1 over 3 plus 3 over c will be 0. So 3 over c equals -2 over c. So c becomes -9 over 2. So our plane will be this one: x over 2, y over 3, z over -9 over 2 equals 1. So let's write in this form. Two times z over 9 minus 1 equals 0. So yeah, we can make this one 9 times x, 6 times y, 4 times z minus 18 equals 0. So this is the plane. Okay. Okay. This is the plane. Okay, let me show this one. Okay, this blue one is the point intersection of the plane and the x-axis. The other one is this one. So this is the y-axis. Okay, it is not passing from the origin.